Hi guys, welcome back. This is part 2 of the build of the dim bulb tester, or the current limit tester. Unfortunately, it had to be 2 parts because there was so much information I was trying to get across to you guys and to get you to understand how this works. Sorry if I repeated myself a few times. I was just really trying to get you to understand what was going on. Anyway, grab yourself a drink, something to eat if you feel like it, and let's get on with it. Okay, so right, we're ready to start putting this thing together now. So what I will do is, won't lose those. Press start. I think I'll put the bulb in over the back first, so we just need to make sure the wires are, so that's why I'm saying you need a copy of your diagram. So what happens is we have the power coming in. From power in, it goes to our fuse. So it comes in from here and goes to our fuse. So actually, let's just follow the circuit through, shall we? I think that might be the better way to do it. So grab our cable, because basically our cable is going to be going from one side to the fuse and the other side to out. So what we could do is, if we want to, we could put a cable tie around this now, so it'll stop it pulling all the way through the hole. And then what we can do is then strip off our wire, run our wires, and then we can put a cable tie on the other side. We can leave a piece of the plastic on here because we don't need it all stripped off, and put our cable tie around this other side. Alright, so hang on, I'll just grab a couple of cable ties, Okay, so I got the cable ties. The other thing we could also do is put a little bit of tape around the cable to make it a bit tighter going through the hole as well. But it depends how far we want to over-engineer this, guys. This is why we need the wiring diagram, guys. So we need to come in, the live needs to go to the fuse, the neutral needs to go to the one side of our switch, which is going to be in the front here. So that should be long enough to there. So we'll take that, and so what we can do is, so we don't keep forgetting whereabouts, got to put this, we can put a mark on the cable or get a bit of insulation tape and probably just run it round. 1 or 2 loops would be probably more than enough, and then pull it off. And so let's just put a couple of loops around there, which then should tighten that up going in. Yeah, that's made the hole a lot tighter going in. It's alright, so now we know how tight that is. So now what we need to do is cut the rest of this off. Right, so that's got my wire all ready. Now, a nice thing to remember, now if you can't remember your colour coding for what is what, generally hot is red, so that's your phase, and neutral is generally black, which is your cold side or your return side. So with the new colour codings they have now, which is usually brown, blue and yellow with a green stripe, the way I remember it, that I taught myself, was if somebody hits you, you become black and blue. So therefore neutral becomes blue, so black with blue. So the other colours that are left would be then brown or yellow and green. Well, the green's in the yellow and green for a reason, for an herb. So therefore the closest colour to red has got to be brown. See, so just by taking it, it's a bit like Ohm's law, just by taking one out you can work out the others. So when you start going past normal single phase power, it gets a bit more awkward because the colours change and there's more wires, and that's because they're running multi-phases, etc. But that's not what we're doing. So we'll get the wire and we'll poke the wire through. So that should sit there nicely. And so the phase, which is the red one, is going to go to our fuse, and the blue one, the neutral, is going to our switch, because that's got to go from out to our power outlet. Because you've got to remember, with our switch, we're switching both phases because we're trying to make it safe. Okay, right, so that's fine, those will be fine. So what we can do is we can put a cable tie around here. Now if we wanted to, we could probably get a bit of hot glue or something like that, but then if we need to replace the cable, it becomes an issue. See, the thing is make things secure but easy if you need to repair them or replace them. So in New Zealand they have a term for it. They call it the number 8 fence wire mentality. And that is that if anything breaks, you can fix it. And that went off somewhere, we'll find that later. So now with that cable tie on there, we should be able to pop these through, push that through, and that's not going any further, that cable tie. So if we put one on the other side, then that's going to be in there nice and secure. That's right, so this one's got to go to our fuse. So, and it doesn't matter really on which one of these the phase goes onto, because the fuse is a fuse, but I'll put it onto the shorter one, and then I think the out will come from the longer one on the fuse. So that will go to there. So we'll give it a little bit of room. So yeah, we can probably use the whole lot. We don't need to scrimp on it. As you just saw then, I tried to cut and pull it the way you think you'd use the pliers, but now if I actually turn it and put it backwards, see how much easier it is. I was telling you that a little while ago, guys, is that the easiest way to strip wire is you use the pliers backwards. You don't use them forwards. It's the way the blades are done on them that's actually putting the pressure on the point you want to actually cut, and it pushes it off. Makes it a lot easier. So okay, so what we can do is we can pop that in, take the nut off first because we don't want to solder it in with the nut on, and then find we're not going to get that on. Now the nut has to go over the wire, because you've got to realise the nut's got to go over all this and tighten. The nut's got to go over all this and tighten up from behind. So the nut has to go on your wire. So then we pop that through there. And I mean, we could stick the nut on, I suppose, if we want to. So that wouldn't be a bad thing, eh? So yeah, we'll put the nut on. Might take me a little bit of fiddling to get this thing on. They're not always known to be the easiest things to work with. Okay, so we'll do that up, and then all we need is just something to give it a bit of a tighten. That's it. Turn that round, and so then what we do is we twist the wires so they don't splay, and we'll tin this, and then we'll bend a little hook in it to put it through the hole. All we're doing is putting a hook in the wire, so that what we can do is then put it through the hole, and then with the pliers we close it up and then solder it. Okay, so that's on there. So as you can see, that's solid. That's the pressure of the spring inside that for the fuse. So now what we can rotate that around so it's easier to get to the top one now. So what we'll do now is we'll put that back, and our second part is we need to go from the neutral to the switch. So this is our main switch. So now what we need to do is to work out which is on and which is off. So what we do is we'll grab the multimeter, stick it onto ohms, and so what we'll do is we'll work out which is on and which is off. So that is on, that is off, that is on, and sorry, let's put it in shot for you. So that is in the on position. That is in the off position. So we'll check just to make sure it is only, they are single poles. So is that one? Yep, that's fine. Yep. So they're individual poles, which is fine. So we'll test this side. That is off. And that is on. So the switch is fine, and so we know that where the two pins are, when the switch is down, that is off. So if you switch it up, that is on. So depending on how you want to set your switches, usually when you flick them up, they're off, and when you flick them down, they're on. So we want it this way. So that is off, and that is on. So we just double check that. So if that's in the on position, we should get, yep, and that's in the on position, so that's fine. So that's the way we need to put our switch in, is that way around. And so I want that close to the fuse. So as I say, the hole that was in the side here was really good sizing, because these just push up and then clip in. And so as I say, all I do is got to put something in here. So that's in the off position. So we can either take it from one of the middle ones or the top one on one side. Right guys, so I'm just having a quick look at this, and I'm looking at the box, and I think I've got the switching upside down. Because if we turn it over, the switch is there. If we turn the box over, they're going to be at the bottom, not at the top. So it needs to go that way, that way up. Well, that was almost a classic mistake, wasn't it? Well, because they're plug-in, we could have pulled it all out and started again. So, but if we catch it now, it's done. So right. So what I'm going to do is, I've got a bit of paper here. So I've got two different coloured pens, so we can have one for phase, one for neutral. So black and blue, blue will be neutral, and green will be phase. So what we've done so far, we've got our cable here. So we've got our live coming in to our fuse. So that's where we are at the moment. And we've got our neutral coming in, which comes down to the first side of our switch going out to our power socket. So what we've got to do is crimp a connection on the end of one of our cables. And so how we do that is we use a little tool, and I bought this as I was saying quite a while ago for doing my vintage truck. So we use this to crimp the cables. So we've got to crimp that connector on the end of this here. So what we do is we get a crimp and we put it on the side. The crimpers have writing on one side, and it tells you the actual physical side of the connector you're using. The other side doesn't. So when you put them in, generally you find that the ends are splayed a little bit, but the back of the plug goes out the side where the writing is. So you put them in and you gently close it until it goes one click, and I'll bring it up so you can see it. So that's the end that goes into the end where the writing is. The other end comes out the side. So then what you do is then you get it you slide your connector in, and then you pull down onto it until it actually clicks. And then generally what I do is I drop the next one down and do it again. And that sometimes I find that when they crimp, sometimes it doesn't crimp tight enough onto the wire, and that's generally because sometimes the wires are a bit thinner inside the plastic sheathing, and you'll get them and they slide off, and then it's like you've wasted it. That's generally what I like to do it twice, and then the sheath goes over it. And so then that's actually protected now, and it can't short on anything, and you can't touch it and get a shock or anything off that with the cover over it. Alright, so that's what we do to the blue one as well. I just had to make sure that the connectors will fit onto these wires, so I did that one before, and I just wanted to re-show you how to do them. So that one's our neutral, and so that will go onto one of our plugs. So power coming in, we might as well put it on the bottom one. So now we've got that done, so it's our phase and our neutral done. So our neutral wire is plugged in, which is this side, and we're here to our fuse. So now we need to go from our fuse to our other switch and to our light bulb. So what we'll do is, okay, so what we're going to do is we're going to take this wire, and we're going to use this wire to go from our switch to our light bulb, and then we're going to have one that comes from our light bulb to our switch. So it'll be a double headed wire there, so that's fine. So we need a second one of these. So what we're going to do is we'll probably use, these were the original ones that were on the back of those switches and on this switch here. So what I had to do is I sat down with a meter, and I'll just show you. So I had to work out which end was being switched and which wasn't. Because these have the neons in them, what I worked out was that the live come in the top, and the neutral came in the bottom, and they were looped. They were looped across like that, across the two poles. So it was looped across the two poles on the neutral, and the same on the phase when it was coming in. And so these were just the outputs. So how these worked was, when you switch them on, one side of the neon is on the neutral side. So when they switched on and the power comes out the center tap on them in the middle, so when the power switches on, the phase goes from here to here. And so then it runs through here, through the neon, it lights neon in here. So that's why I had to find out which way around they worked. So I'll just show you that. I'll just put the meter, I just put the meter on to continuity mode. So if I go into neutral and go to the center, there's nothing. If I go from neutral to live, there is nothing. And that's on the on position. If I turn that off, neutral, center, nothing, neutral, live, nothing. But now if I go from the center to live, if it's off, it is nothing. But if I turn it on, it makes a connection. Now both the individual poles are exactly the same. And that's how I worked out how that switch works. So when we put it in, we have to put it in such a way that the lives need to go up. So when we're turning the bulbs on, they got to go down, which is towards the base of this. So just like I got mucked up with this one is the live has got to go to the top, the same as what the main switch does. The live's got to go to the top. So what I'll do is, because these are looped, I'll actually use these to go across those two, and the same with the neutrals. And then what we do is we tap off from here, from one of these will be for this switch here, and then if we want the second one, that'll be a second switch that's going to be in here. Alright, so we'll get on to that. You'll see it in the drawing and as we carry on through this. But I just wanted to let you know how this works. The neon inside that one works very similar, in that when there's a connection on one side and one on the other side, that when it gets switched over to the live side, when the power goes through the other side, that's what makes the neon go on this side, rather than the side that's there that's not connected. So you'll see it when it's powered up anyway. But that's how that works. So it's about as clear as mud, I take it. That's good. Right, so we'll turn this off and we'll carry on, shall we? Right, sorry about that, guys. I was just working out how the switch works. So other than the basics, how it's going to work in this diagram. So what it will be is, then when it is up, it's obviously going to the light bulb. So then when you switch it down, it goes through the circuit. So that may be an issue for us if we're using more than one light bulb. But if I'm only using one, it shouldn't be. It should be. Well, the other thing I can do is I can always pop one of these off anyway and just run one side. Yeah, I mean, it shouldn't really matter because I'm only using one of them anyway. But anyway, yeah. We'll do it that way anyway. If it doesn't work, we can always take it out and do it again. So what we'll do is we'll tin these two wires. Then we've got to make another one the same as this for the other side. So we can jump her across here, and then the side of the center one is this connection going over to here. Okay. So we have our switch. So now what we've got to do is we've got to do the wire from the fuse to our lamp, and then the other side of our lamp goes to the switch, and then these ones also go to our lamp. So we need to make up another one of these. So I don't have any more of those boots, so I'll have to grab one out of my kit. And then what we can do, oh no, we can probably not have one on the other side, actually it'd probably be alright. So what we can do, we can strip this off and crimp it onto one of our plugs with the other one. So what we'll do is we'll put these two wires together, we'll twist them both together, and we'll get one of our plugs. Through and crimp it. Now because that's a thicker wire, that's fine, that's not going anywhere. So if we really want to, we can put a little bit of something around that, so put a little bit of insulation tape around it, I suppose it'll be okay. It's just at the very end there, so I think it should be fine. And so that one, it's an out, so we'll go on this side from here over to here, and then I can pop this one off and stick a little bit of insulation tape on that one as well, actually. Right, so that one there, this one goes to our other switch, so this will be to the in. So what we're doing is we're going from our fuse to our light bulb. So we need some more wire. I've got a whole pile of the white wire there. I just stripped the cable off it, just tearing it down, pulling it off. So we need to go the live from our light bulb to our fuse. So we need to strip a piece of this off and tin it. Anywhere. Right, so then from this, that will come over. Cut this one. Cut that. Okay, so now what we'll do is we will solder the wire on our switch. Now this is the wire, this is the main feed, which is our live in, our phase. So to connect these up, so what I'm going to do is I'll go from the fuse to the light bulb, then from the light bulb to the power in on the switch. So that's the circuit that's live all the time, because then the other side of the light bulb goes out to the power socket. So what we will do is we will solder these two wires together. Put a bit of heat shrink over them. It's just a little butane burner thing. I picked it up at super cheap over in Aussie when I was over there, when I bought the other bits as well. I had a look around and super cheap had them. They were like $3 and they're refillable. And I thought, what a handy little for doing heat shrinking. So anyway, so that's done. So that one's in there. That one's set to go to our mains switch. And then we need to put one on here for our neutral. So we need a neutral, the one that goes into here. We need one that we can use for the lights to light up in here, or otherwise we're not going to have them coming on. So we can tap it off the bottom one where it goes out to the switch. So get some wire, cut a piece of that off. So do is we will tin these two. Put a bit of heat shrink on there as well. So we'll tin these two up and solder this one on, and then we'll look at trying to put this all together. Right, so now we've got all those ends all done. Now we can work on where we're going next to with this thing. So we know that this has got to be our out. So that'll be this side. So this side of this switch has got to go to the other side of the other switch. So we do that. And the light bulbs have got to go to that side of the switch as well. We may have to take this off and put a wire from here to the other side of the light bulbs. Okay, so let's put this switch in here so we can get this sorted. So pop this one in, pop these two in. Don't want that to go all the way through. Now we've got to have the live towards the top, which is the way we want it. Okay. So this one is our power in, which is going into the same one. Okay guys, sorry I got myself a little bit muddled there. So what we're going to do is the switch has got to come from the fuse as well. So the input has got to come from the fuse. So I'll just tin that up and put that on. Okay, so that's done. So we have a power coming into the fuse to the light bulb, from the fuse to the power in on the switch. Okay, so we got our fuse, so we're going from the fuse to our light bulb, we're going from our fuse to the switch. So then we've got to go from our light bulb to the switch, which goes out to our power socket, and we've got to go from the light bulb, from the switch, sorry, to our output switch. So we need two connectors off there. One is to go to the switch, which is this one. So our switch will come out and go to our switch, and we need one from the light bulb to our switch. So what we need to do is we need to take this off, and we need to put a second one on that. So cut this one off and we'll replace it. And won't be able to put the boot on it, so we'll have to put some tape around it. So 1, 2, and so our switch and our light bulb, which are these two here, so which is this side of our switch and this side of our light bulb, are going to come around over to that side of our main out switch. Those together, so we get the crimpers. Wires in, crimp it down. Those are fine. Okay, so those two are done, and so that one then will go out to the other side of our light bulb, or light bulbs, depending on how many we're putting in. So I'll put a little bit of tape around that. Just as a bit of a protector, that's all. So that one go onto there, and that goes out to our light bulb, which is the second one to our light bulb. And so then the other two we've got down here, the other two connections from here will go to our socket, which is going to be up on top. So what we can do is wire it up from in here. We need a black, so this has got to go to the neutral on our switch. So this is for the lights that are in the top one here, so we need to do a double connection on that one, so one for the neons in here and one to go out to the light switch. So put a little bit of tape around that one too. And then what we can do is we can use that black boot on the positive one that goes out to our power socket. So, and the thing I was saying about using these push-in connectors, so to put this one on the bottom, we just got to pop one off, pop the other one on. And that's what I'm saying, if any of the plugs or that ever fail, or there's an issue with them or anything like that, it's easy to actually replace them. So what we'll do is pop you over, and that's our negative or our neutral out to our switch, out to our socket, sorry. And so what we want, can cut a piece of this one off. We don't need it to be terribly long to go to there. Cut it off here. So I don't know if I've got any more red. Hang on, let me have a look. Oh yeah, I got a piece in here. Pop that off. So then we can put one of these on, and looks like we've got just enough with one left over. I have to get some more of those. It's amazing how many of these things you need when you're wiring a car, I can tell you. Just make sure, so it is only the one we need to go from here. And what we'll do is do that a second time, just to make sure it's crimped on. So, and we can slide the boot down over the top. That one should be out from here. Slide you over, and then that one goes on to there, and then this one can come underneath everybody, and go out through the top. Okay. Right. And I think that is us. So I'm pretty sure this is all done inside here. So what we can do is, we won't seal it up yet, so we need to push that in, and we need to wrap a cable tie around that side, so I think we can do that now. So that's going to be fine. So if we're really worried, we could drop a second one in behind there if we wanted to. So that'll just doubly make sure it doesn't pull out, or push in I should say. Push up against the other one, pull it tight. So that's going to make sure that definitely doesn't move, so it doesn't pull out. So right, so those are in there. So now we just got to take this and we turn it over, and we put our pieces on the top. It's taken a little bit of a while to get here, guys. It's not a 2-minute job. That's the thing you got to realise. It's not a 2-minute job to do everything. So it does take a little bit of time. And also, while I'm explaining it and doing it too, it does take a wee bit of time. So what I will do is just clean this off a little bit, and we will go to output. Put them on the wrong side, didn't I? Just as well we're checking on this. So that's the side it's meant to go to the output. Should remember to look at the fuse. If I looked at the fuse, I would have known what I was doing. That is our outlet, and this is our light bulb. So we can come under here, and through that. So yeah, and you can come over here and go down into there. Right, this time we have it right. So that is our power, so that's fine. So we can cut these shorter if you want, but if you want a little bit of room to move with, you can leave them a bit longer. So I think that should be way long enough for what we need. So strip off one end. Why come off on the inside, so I'll have to have a look at that. That one as well. Right, so as you come off of. So obviously, as I said to you, sometimes just crimping them once is not enough to hold them. And there's the proof of it. Right, so we can take that and we can pop that back through again. And stick that one on there. Slide the boot over. Put that one back on again. Right, so now we've got that done. Now we can get back to putting these back on again. So this is our socket, and we've got those, that done, and so phase and neutral. Most of the time you'll find your sockets and everything are labelled PNE, so phase, neutral, earth. So phase is red, so that one will go up through there. Phase, and the opposite side is neutral, so we'll pop that one up. Right now, so the only thing is that if you are going to use a metal case, a steel case that's painted or something like that, you're going to have to use earth. Alright, you're going to have to use it because you're going to have to ground the case. So the earth that'll come on you, if you had a metal case, you need to use the 3-pin connector, because the earth will have to go and ground onto the case, and then it'll go from the case to the earth on the plug. You have to do that in case anything happens, the box doesn't come live. Okay, so just something to be mindful of is if you are going to use a metal box, you're going to have to earth it. And that's just practical sense tells you to do that. But not only that, electrically you have to do that. You have to earth the metal case. And a lot of the 2-pin cables that you get now, why they don't have the earth is a lot of them are double insulated, so you should not get a shock from them, or they should not be a potential risk of shorting to ground and giving you a shock. That's why a lot of the new stuff nowadays doesn't have the earth pins on them, because the that one on, because that one's tight and it screws into the plastic. It's quite good. It saves me having to push all the rest of it in. And so just make sure that wire pops through so we can put them onto the lighting bulb. They can go through to there, And we'll get the nuts and we'll put the nuts on the other side. And that's the only thing. If you got big hands like me, this is a pain to bloody do to get small parts into these places. So sometimes you put it into a big box and you think, my God, what do you want that for? It's because it's easy. So that's just sometimes why things get done like that. So now we can strip the 2 wires on here for our light bulb. And because our light bulb is basically a resistor, it's been used as a variable resistor, it doesn't matter which way around the wires go. And that's how with the light bulbs you can actually take these off and you can get normal flat bases for them. And that if you really wanted to, you could always cut this square or flush so it'll sit flush, but I don't mind it. So pop that over there. Whereas your Edison, your MS or your Edison screw only has the 1 pin in the very centre, whereas these being Bained, it has the 2 pins, one either side. This outside part is just to hold the bulb. It doesn't carry electricity, it's just to hold the bulb. So then now what we'll do is we get our base. We pop our base in. And then when we put our base in, the ring goes over the top. And then just with most things, as I find, if you go backwards, you'll feel, if you go in the opposite direction to like undoing it, you'll feel it will go click when it drops into the thread, the beginning of the thread, and then you'll find it's easy enough just to screw it down. So this just locks the bulb holder into the bottom of the base. I don't know if you can see this. So when you put them in, the tabs go either side of the mounting posts. So when you tighten it up, it doesn't move. But if you want your posts and or the pins to a certain direction, you don't have to, because it'll hit one of these posts and it'll stop it moving past it. But anyway, we digress, and I will go on with screwing in these. Right, so we've still got our little gap in the front here, so we're finished with this. We're finished with the soldering iron. Put the soldering iron away. So what I'll do is I'll just move all this stuff out the way, clean all this stuff up, get rid of all the mess that's around here and that. We'll come back, we'll put the top on this, we'll just go over everything and double check it and make sure it's all to what the plan says, and then I'll pop a fuse in here and we'll give it a go. What do you think? Sounds like a plan. Right guys, all cleaned up now, the desk's all tidy. What I might do is I might stick myself up in the top left hand corner just so you can see what happens down underneath here. So just hang on a second, I'll switch me around. And there we go, that's a bit better. So now you can see what's going on down the bottom here. So right, I've got it all together. I found a fuse, a 5 amp one, which probably a bit of an overkill, but it's the smallest I've got in the glass type fuses at the moment. So I will use that for now. Right. So what we're going to do is pop all this on, and I will use the multimeter and we'll just double check that everything is working how it should be working. So before we put any physical mains into it, we will just check it out and make sure that everything is working as it should. The last thing we want to do is to make a low current device to stop things blowing things and blow things up ourselves. So that, we'll pop a bulb into there. So what we'll do is get the multimeter. Let's put it onto continuity mode. And I'll put my eyes on. And so what we want to do is to make sure there's no shorts across here. So go from there to there. No, and there's no shorts there. That's good. First one down. So we want to make sure we're going through the fuse. So we go on the back of the fuse. Come from the back of the fuse to the side. Yep, and that's fine. So we're getting continuity through there. So then we want to go up. So we go from the fuse up through the light bulb and back out the light bulb. So what we'll do is we'll go from this side to that side of the switch. And yeah, so we see the light bulb in there. So that's cool. So we're going through into here, and then from there we go into the other side of our switch. So we shouldn't have anything out on our help. It'd be actually no, it would be easy if we had this off, because then I can get the probes I have on the end of my multimeter are not long probes, because otherwise if you had the long ones you could pop it down into here. So what I'll do is I'll pop this off. Don't lose that. So we can go into our phase, which is on this side. So we can pop into there. Well, we can go into there, actually it's the same thing. From there to the other side of our switch, and there is nothing there. We turn it on and we have a connection. So that's working. So therefore that then should run through either straight from here, and then if that's on, then it does. Okay. That's there. So yeah. So that's showing us it's going through the light bulb. So when it's down, it's not going through the light bulb. Okay. So that seems to be all fine. So that all seems to be working fine. So the next thing to do is to put that cover back on so I don't electrocute myself. And then would be to plug it in and plug something into it and see how we go. Right, so that's all in there and done. So put that away. And what we'll do is we'll put the bulb in there, and our next thing to do is to get something to plug into here. So give me a sec and I'll see what I can find. It's a 14-inch or it might be a 13-inch compact LCD screen. So I've plugged this into the mains. It's turned on in the mains. So this was just close to hand because it was mains related. So what we do is we plug that into there, and I'll just turn it around so you might be able to see the little LED on the screen down here. So everything is turned off. So what I'll do is I want to see if there's a short on this or not. So this will have the bulbs turned on. So if I turn the power on, did you see that? Did you see the little orange flash? So what that says to me, and the light is on the front of the monitor here. So we know that this is good, so then turn that on and turn that on, and it works fine. So that when we're in bypass, you can see when we're in bypass mode, the LED is on. So this one here, the bulb must be no good in it, or it doesn't have one in it. So if we turn that off, so now if we're going through the bulb, the light doesn't come on, and you see it just flashes. That's because this is pulling, it's charged up the circuit in here, and that's it. There's no more current going, so that's why it's turned itself off. So now if we switch that down, now this is in bypass mode, so it's coming in and going straight out to here, and the light comes on to so it's on. The light is on the monitor, and if we push the power button, we can turn the screen on. So that's working fine. So as I was saying, if there was a short, this will come on and stay on bright. Now I haven't got anything at the moment that's faulty to do that for you. I don't have anything in here that I can plug in that's not working to show that to you. But this just proves that it's working. Now we can change the bulb. I can try the other bulb. Another bulb I have. Now this will tell us if the bulb's any good. So you ready? Set flash. That's telling us that the monitor light is on. I don't know if there you go, you can see it there, the green monitor light. So see how this is pulsing? This has got power correction in it, and that's why it's doing this. It's trying to power up the screen. This is what a power supply may do to you with its PFC circuit. Okay, so I'm very glad that this screen did this so I could explain that to you. So then what we did is if we actually switch that out and turn that on, now that's out of the circuit and not taking all the current away, this will run fine. So, and it's not flashing anymore, as you can see. So it's not because the PFC in here can take enough power to actually power this on and run it. And it actually comes up and it says, oh, check your connection, you've not got a video card plugged in or whatever. Alright, so that's just something to remember. And as you can see, these are quite handy. So on and off for the bulb. So put down bulb and then put bulb on, bulb off, and then just put your off and your on down here if you like. So but that's what it is, guys. They're a great little tool, and as I said, you'll save yourself a lot of hurt using one of these. You can scale it up. You can make it, well, try and make it a bit smaller. If you find it's getting too bright, the wattage is probably not high enough, so you probably want to put something a bit bigger in it. But as I say, you don't want to go much past, 140, 160 watts. Alright, so there you have it. There's your little box, there's your magic box, and hopefully it'll save you guys some heartache in the future. Okay guys, that's the end of this one. I hope you see the benefits in this in the end. It's a really cool piece of kit. I may revisit it later on, and we might make a more upmarket version, maybe with the USBs and that. I've had a few ideas of how to tweak it a little bit and add a bit more splash to it. But as some people say, keep it simple, stupid. Anyway, you guys have a great time, and we'll catch you on the next one. Ciao.